Process of solving polynomial equations. This is annotated in our class notes under solving polynomial equations, but this will hopefully clarify it for you. We're going to go step by step through the process. So please come along. Let's begin with something we're familiar with. How do we solve an equation like this? Technically, this is a polynomial equation because this is a polynomial function on the left. And we have solved equations like this for a while, since we were in grade 9 likely. So how do we solve an equation like this? Well, we know that we want to isolate the x to solve the equation. Therefore, in this case, we may want to add 5 to both sides and then divide by 3 both sides. So at the end, we arrive at x equals 5/3, which will be the solution for the equation. And we now will expand this concept to this notion of the roots of the equation. And in this case, this equation only has one root at 5/3. When x is 5/3, this value makes the equation true. We can also think like this. We can also think that the x-intercept of the function 3x minus 5 is at 5/3. And that is the root of this value. So we have very quickly reviewed solving a very simple linear equation algebraically and graphically in a fashion that we're familiar with. Then we move to quadratic equations that we solve likely in grade 10, grade 11. An equation similar to this. And in this case, we do have several alternatives to solve these type of equations. We can always use a quadratic formula. But in this case, for example, we could factor. We can see that if we find factors of 6 that add to 5, they are 3 and 2. So I can rewrite this equation in factor form as x plus 3 and x multiplied by x plus 2 equals 0. And from there, I can easily identify the zeros, right? We can always solve by graphing. So from our factor form, we can see that the roots of the equation, or the zeros, are at x equals -3 or at x equals -2. So our graph might look something like this. Okay, then this is a new type of equation that we're going to solve. And we're going to benefit from what we have learned about remainder theorem and factor theorem. There is no equation to solve a cubic function like this one. So our strategy is going to be this. We first are going to try to find a factor for this polynomial equation, this cubic equation. And we're going to focus on the last term, on this -6. So our first step is to find factors of -6. And here we have all the factors of -6. So -6 and 1 with both different signs, and 3 and -2, or vice versa. The purpose of this is to identify one of these factors that will produce a remainder of 0. In other words, we are trying to identify a factor. So how do we do this? Well, we basically try the values until we find one value that makes a remainder of 0, and that means that that will be a factor for the equation. So let's see. Let's imagine that we know that 3 is a factor of 6. So what if we evaluate the function 2x cubed plus 3x squared minus 11x minus 6 at 3? And when we do that, we can see that these values, we have 2 times 3 cubed plus 3 times 3 squared minus 11 times 3 minus 6. And just at a glance, we can begin to see that this value is going to be greater than 0. Actually, I do not need to calculate exactly the value of f of 3. All I need to know is that it's greater than 0. Because what I'm interested in finding a factor that produces 0. So if this is greater than 0, I know that x minus 3 is not a factor. So then I move on and explore a different one. Let's try 1. 1 is always a good value to try because it's very friendly to substitute. So we do the same process. We substitute 1 in our original equation, our function, excuse me. And when we evaluate it, we realize very quickly that this value is going to be negative. So it's not going to be 0. Therefore, x minus 1 is not a factor either. Okay, let's continue. Then we evaluate f of 2. When we evaluate f of 2, we see that we have this calculation, 2 multiplied by 2 cubed plus 3 multiplied by 2 squared minus 11 times 2 minus 6. And lo and behold, this equals 0. So this is good news for us because now we know that x minus 2 is a factor of this cubic function. And that was our first step. So now that we have this equation and we know that x minus 2 is a factor, we can find the next factor by using division. Because we know that x minus 2 is a factor, then I can divide 2x cubed plus 3x squared minus 11x minus 6 by x minus 2. And I know that the remainder is going to be 0 because of what we learned earlier about factor theorem. And so I will do these using synthetic division. And here is the process. I'm not going to go over it in detail because by now we know how to do synthetic division. So I can see that the coefficients of the function are set up here, 2, 3, negative 11, and negative 6. The 0 at 2 is here. I have my division set up, and then these are the coefficients of the quotient. So that means because I'm dividing a cubic into a linear, the quotient is going to be 1 degree less than the cubic, therefore quadratic. And here is the second factor, 2x squared minus 7x plus 3. And this 0 tells me indeed that the function had a remainder of 0. Very good. So now taking this again into perspective, this is what we have done so far. We found a factor of negative 6, in this case 2, and we realized that that's a 0. And then we executed a division and found that 2x squared plus 7x plus 3 is another factor. And because these two, their product is 0, we know already that 2 is going to be a solution, but now we need to find the solution to this quadratic equation. 2x squared plus 7x plus 3 equals 0. And we can solve these in a variety of ways. We could use the quadratic formula. We can always try to factor it. So here's a solution using an area model for factoring. If you use a different model for factoring, that's fine. Whatever model works for you, whatever methodology works for you, it doesn't matter because the factors are going to be the same. The factors for this quadratic are 2x plus 1 and x plus 3. So we can then find that our equation in factor form became this. In other words, 2x cubed plus 3x squared minus 11x minus 6 equals 0 is equivalent to this equation in factor form. X minus 2, 2x plus 1, and x plus 3. And from here, it's very easy to see that the solutions, the roots are at x equals 2, x equals negative 1/2, and x equals negative 3. So if we did a little sketch here, we can see that our graph, knowing that it's a cubic function with a positive leading coefficient, has this shape. We will have a 0 at negative 3, we will have a 0 at negative 1/2, and we will have a 0 at positive 2. We can always solve a polynomial equation graphically. So if we were to graph these, say we enter it into Desmos, we would see that indeed negative 3, negative 1/2, and 2 are the x-intercepts that work for this equation, or the values that would make the equation true. Well, let's continue then. So here's another example. How do we solve x cubed plus 7x squared plus 2x minus 40 equals 0? Well, we're going to repeat the process. We are going to find factors of negative 40 that when we evaluate them will produce a remainder of 0. So we're using, again, remainder theorem or factor theorem. And we can try factors of negative 40. We know that 8 and negative 5, or 5 and negative 8, 4 and negative 10, and vice versa, etc., etc. So in this case, we're going to expedite these and realize that if we evaluate at 2, when we do f of 2 for this polynomial, that happens to evaluate to 0. So in this case, we got to our factor rather quicker. X minus 2 is a factor because when we evaluate f of 2, the remainder is 0. Perfect. So we continue with the process just like we did before. If we know that x minus 2 is a factor, now to find the next factor, we are going to execute our division. We're going to take x cubed plus 7x squared plus 2x minus 40, divide by the factor that we already found, which is x minus 2. And just like before, because x minus 2 is the divisor and the coefficient here is 1, it's easier to do synthetic division. So here's our synthetic division set up. The coefficients of the equation, the cubic, 1, 7, 2, and negative 40, the 0 that we found from our factor, and then the process. And the process produces this second factor, x squared plus 9x plus 20. This is a quadratic, and hopefully you can see quickly that it factors to x plus 5 and x plus 4. In other words, we were looking for factors of 20 plus 20 that add up to 9. So 5 times 4 is 20, and if I do 5 plus 4 is 9. So the full factorization of our equation now looks like this. X minus 2, which was the first factor we found using remainder theorem, and then when we factor the quadratic, factor 2x plus 5 and x plus 4. And then it's very easy for us to see that the roots then would be at x equals 2, x equals negative 5, and x equals negative 4. And that would be the solution for our equation. We have a little sketch here, just a sketch almost by hand, really, that we have a 0 at negative 5, 1 at negative 4, and 1 at 2. The important part for this sketch is for us to see the shape of the graph as well, because we know the leading coefficient is positive. That means the function begins in quadrant 3 and ends in quadrant 1. Of course, we can always graph this, and you can see here a solution from Desmos that has been graphed. And you can see that the solutions are at negative 5, at negative 4, and at 0. Well, let's try 2 more examples. Here's the next one. And I want you to look at it for a moment before you continue with the video and think. You can pause the video and think, how is this example different from the previous 2 that we just did? So pause it if you need to and think for a moment how this is different. Well, if you notice that in this case, we do not have a term that is an independent term. In other words, every term in our equation contains an x. You might have wondered if we could factor that x. And alternatively, you may have wondered that if we were to substitute x, this equation would be true. So in other words, one solution to our equation is x equals 0. Because if I were to substitute 0 everywhere, this would be true. But I can also express that as a factor like this. So if I factor the x, I would end up with a cubic equation inside the bracket. So when I factor the x, I end up with 2x cubed plus 5x squared minus 39x plus 18. And x equals 0 is already one solution. So technically, I factor this already. I have 2 factors, x and this cubic form. Now we need to repeat the process we did before to factor this cubic portion. In other words, find factors of 18 that would produce a remainder of 0, do our division to find the factor and the other factor that we need. So in this case, we're just focusing on the equation inside the bracket. So if we try 3, because 3 is a factor of 18, of course, this might come after a few tries with different values. We realize that f of 3 equals 0, which means that x minus 3 is a factor of our cubic equation that was in the bracket. So now we are going to do a division to find the other factor. So think about it. We found first a linear factor with x. That was easy because we just factored it out. Then we found another linear factor, x minus 3, from the cubic. Now, when we do the division, we're going to find a quadratic factor. So this is our setup for our division. Again, synthetic division, because this is x minus 3, and this is our next factor, which would be 2x squared plus 11x minus 6. I hope you can see that. If not, you can verify it. So now we need to find this. So now this factor, this is the second factor. We're going to factor it yet one more time to fully factor our equation that was quartic. And these factors to x plus 6 and 2x minus 1 equals 0. So then keep in mind that we're not showing the factorization, but you can review it, you can verify it. And if you have difficulty with factorization, please see me to clarify it at some point. Okay. So now our equation is equivalent to this one. So our original equation, 2x exponent 4 plus 5x cubed minus 39x squared plus 18x equals 0, is equivalent to this equation. X, and then 3 factors, x minus 3, x plus 6, and 2x minus 1 equals 0. The benefit of this, of course, is that we can see the solutions very easily. And here they are. X equals 0, that we knew. X equals 3, x equals negative 6, and x equals 1/2. So we know this is a quartic function. And if we were to do a little sketch, we know the leading coefficient is positive, so that it would open up and the shape would be something like this. We would have a 0 at negative 6, 1 at the origin, 1 at 1/2, and 1 at x equals 3. If we were to graph this, we would verify that this is indeed correct. We have a 0 at negative 6, 1 at the origin, 1 at 1/2, and 1 at 3. Well done. So we have now solved 3 examples of polynomial equations that are beyond grade degree 2. Here is a final example, and I'll look at it for a moment. This is a quartic function. This one does not have a common x because we need to rewrite it. So think of what would be the first step in solving this equation. Again, pause the video if you have to. What would be the first step to solve this equation? Keeping in mind that the right side is not 0, but 5. Well, if you saw that our first step would be to subtract 5 from both sides so that our equation now looks like this, you're correct. In other words, we subtracted 5 from both sides, and this is our equivalent equation. X exponent 4 minus 6x cubed plus 4x squared plus 6x minus 5 equals 0. And we are going to allow you to solve these on your own. We have the solution in the class notes, but repeat the process that we did, keeping in mind the following. The first step is going to be to find factors of negative 5. And you're going to find factors of negative 5 that produce a remainder of 0. Then you're going to do a division, and you may find more factors. So we're going to go from a quartic to a cubic, and then you're going to have to apply factor theorem again to go to a quadratic, and then you can factor as you know. And the solution is in the class notes. thank you for watching, and I hope this lesson was helpful. And of course, we can discuss this and clarify as necessary in class. So I'll see you then. Thank you.